Alright, this is a slightly more complicated example of L'Hopital's rule. We're going to try and evaluate the limit of this function right here. And if we try direct substitution, we get e to the negative 3 infinity, or 0 times square root of infinity. So we have 0 times infinity, which isn't exactly a form we're allowed to use L'Hopital's rule in. So what we have to do is find a way to rewrite this. So limit as x approaches infinity. And then we're going to move this thing, the negative exponent, to the bottom and change the sign on it. So we have e to the 3x, and we'll leave the square root of x on top, but we'll write it in exponential form as x to the 1/2. And then if we try direct substitution again, we get infinity to the 1/2 over e to the 3 infinity. So we have a form of infinity over infinity, and we are allowed to use L'Hopital's rule. So we'll go ahead and take the derivative of the function on top and the derivative of the function on bottom. Try that. So on top, we use the power rule, bring down the 1/2, and then subtract 1, so we have negative 1/2. On the bottom, we use the chain rule, 3e to the 3x. Find it. And then we're going to rewrite this again and evaluate. Infinity. Up top, we just have 1 left. The 2 and the 3 combined to a 6 on bottom. E to the 3x will leave first, and then the x to the negative 1/2 on top moves down to the bottom and rewrites as square root of x. And when we go to evaluate this with direct substitution, it's 1 over e to the 3 infinity times square root of infinity, or just 1 over infinity, or 0. So we found that the limit of that complicated function as x approaches infinity is 0, thanks to an application of L'Hopital's rule after we rewrote the function. Thank you.